Okay, we stopped at acids, but before we go, I just want to verbally recap some stuff. You all can look at the screen or your notes, doesn't matter. As I said, I don't expect you all to memorize everything yet. If you can, then you all should get full marks. Okay, I'm just going to browse through my notes and ask about some key points. And then you can tell me what you remember. You can try, if you want to test yourself, you can close your notes. If you think you totally forgot everything, you can look at the notes and just try to read me what I want to hear. Okay? So, what helps us make acid? I need what to have acid? H plus makes acid, okay? And how do I produce H plus? Do I just have it naturally? What must I do first? Add water. So all acids are solutions. That means all acids are water. That means you must have water to have acid, right? Can that be a solid acid? Gaseous acid? No. It must be, to be called acid, you must be already mixed in water. Okay? What is the meaning of strong acid? What is the meaning of strong acid? Hey, I forgot. I mean, I also put it on my screen here, so it's so that you can see. What is the meaning of strong acid? Or if you think about it, strong means you're weak, man. What is the meaning of weak acid versus strong life? What? Okay, Xianghui typed in the group. It is fully dissociated. Okay? Fully dissociated. So strong acids will fully dissociate. And in other words, weak acid will partially. So what's the whole idea of this? Dissociation is a big word. So when I was young, I hear dissociate, I was don't know what to German. Dissociate basically means you take the HCl, for example, you split it into. If it's HCl, you split it into. HCl. I wouldn't think that is the best way to say what you said.
Minus and Cl minus. H plus and Cl.
Okay, Keith, I appreciate you're trying, but you have this strong misconception. You keep thinking H minus from last time. Okay, wrong, fix it. Okay, it's H plus. Okay, yes. So you split it. See my hand. So this is H, this is Cl. They used to be a what kind of compound? Covalent. Is this acidic? No, until it touches into H plus and Cl minus, right? H plus and Cl minus. Who is the real acid? H plus. So the Cl minus, there's a name we call it. You can think of it as a spectator. Spectator literally means you go to the cinema or football match. You are the spectator because you are there, but you don't do anything. The Cl minus is a spectator. If you look at my same page, second example, I have H2SO4. A big piece of H2SO. It doesn't look like that in real life. Imagine you throw in the water, split it. You get two pieces of H plus and one piece of SO4 2 minus. Who is the real deal? The two H pluses. Who is the spectator? SO4 2 minus. What is the English name for SO4 2 minus? Sulfate. So sulfate is a spectator. The only reason the sulfate, let me use a pen to show. The only reason we have a sulfate is because an anion stabilizes with a cation. Who is the real deal? Which one will burn your face? It's the H plus that will burn your face. Sulfate, you can drink it, you can touch it, nothing happens to you. Okay? So same for nitric acid. So nitric acid is just another type of acid where you dissociate into your main guy, which is H plus, and what do we call this? In chemistry, you can say this is not a layman word, this is a real word. These three are what we call the spectators. Spectator ions. Okay, they are there just to carry the real guy because anions and cations will carry each other into existence. I cannot have just H plus. Somebody must be there. So in this case, these are the three that we use. Okay. So far, so good. Now, don't turn to your second page. What? Without looking, what is a base? I mean, if you really don't know, then look. Okay.
Is it neutral?
Bases are not neutral. Far from it. Sorry. I mean, if you forgot, you can look up. Second page. The first thing I made you all write 10 bases to remind you all that bases are actually easy to come by. We get a lot of bases. What is the requirement to be a basis? The first sentence of the second page. A metal crisscross with O2 minus would be a base, or a metal crisscross with OH minus is also a base. That's why there are plenty of bases. You go to the periodic table, anyhow take a metal. Can I use magnesium? Can. Magnesium oxide, is it a base? Yes. Magnesium hydroxide? Definitely yes. I use a weird one, never heard before. Francium. Francium oxide. If francium is a metal, you all can verify, just check the periodic table. Francium is the bottom good one. So if I said francium is a metal already, you don't need to verify it is, alright. So francium oxide is a base. Francium hydroxide is also a base. And I can say other things. I can say another weird metal, whatever lah. Okay, you get my point. Now, bases are all over the place. Bases have the ability to neutralize acid. So just now when Keith said bases are neutral, is wrong. If you wanted to say neutralize, then you're more correct. They can neutralize acid. So they are opposite, like yin yang. You know? One black, one white. You know? One whatever, like one good, one bad, right? Now, alkalines would be more specific. It's harder to be an alkaline. What's an alkaline? It must be that one word. Oh, memory so no good. Hello. Alkalines and bases, these two words you hear them a lot interchangeably. Sometimes you don't even know how come what is an alkaline, what's the base. But in my notes last week, we spent some time to talk about what alkalines are. You can read it now and tell me. Online also can try.
Bases, they are
Soluble. Soluble means what? Will dissolve in water. You put in water, stir it up, cannot see anything anymore. Think of sand. And then think of salt. Right? Salt is soluble. Okay, so for soluble bases, there will be four lah. When we go to the alkaline page, I'll explain more. But just a quick recap lah. So we're not trying to take too much time here. Solvents, very difficult lah. I'm not going to show you all the methods now. Just think about it. There are two types of solvent. Who knows the two categories of solvent? Organic and inorganic. Water is inorganic. Petroleum is. Hexane is. All the weird names lah. You got vodka is organic. So all the non-water solvents are organic. Are they capable of dissociating anything? No. So in O levels, all you need to know is the only guy that can dissociate acid and alkaline is water, which is a type of inorganic solvent. Will be tested, always tested. Most people don't know how to answer this. Okay. Last week I told you the example, favorite example. HCl is mixed with benzene. What is the pH? 1, 7 or 14. HCl, benzene is some kind of oily water lah. You throw into benzene. So your HCl molecule, like that, throw into benzene. Benzene, you all don't need to know why. I also don't know what it is. JC will learn again. But what happens when HCl is thrown into benzene? Nothing happens. Any dissociation? No. Is it forming an acid? Okay, somewhere I saw an answer good. Nothing. So what's the pH? 7. This is a common trick question. What is the litmus test? If I dip a litmus inside, what happens? Blue. Litmus is a blue or red paper. I dip it inside, what happens? Think, can electricity pass through HCl plus benzene? Is it an electrical conductor? No, because no ions, no H plus, no Cl minus, right? So this question, as I said, always come out, people always have no idea what's happening. They are trying to trick you because they purposely dissolve it. Awesome. Okay, so take out your acid notes. We are just doing a recap from last week. Okay, so just be careful when they dissolve something in something else, just know what happens and what doesn't. Okay. Universal indicator, nothing much. You generally know neutral is 7. Alkaline is big number or small number? Big. Acid is small. Okay, just be careful. Indicators, just need to know that their point is the purpose is to change color, but don't need to memorize anything. Just know that they will change color at a different pH, so that it helps you differentiate generally what is acid, what is alkaline. Okay, we're back here already. We quickly go through the properties of acid again because you always will be tested. You have to memorize every single. Okay, so I just erase what we did last week so I can talk again. All acids are sour. This one quite okay. I'm okay to memorize it. This is one fact that I always remember. It has a red. It will turn litmus red in color, which I'm okay with because I believe I said last week. So think of danger. You think of acid as danger. Okay, danger is red. The color red is the color of danger, so we think of danger. Now, they all have H plus. This is the first thing I emphasize in the chapter. Acids will dissociate into H plus and Cl minus. Hydrochloric acid, H plus Cl minus. The anion can be anything. Can be chloride, can be sulfate, can be nitrate. No big deal. But the H plus that is the key guy. The last part is what a lot of students cannot memorize. Why is it electrical conductor? Those of you who were here earlier in this year, I already told you to conduct electricity, you need mobile something. Or I mean, we wrote last week, so don't need to write down again. Okay, so we need mobile ions or electron. So if I don't have, I cannot conduct. Acids will have. Why? Because they have gone through the process of, the proper word is, so they have been dissociated. What used to be a molecule now is 2 ions. Last time molecule can conduct. Cannot. When you come down in the water, split, can conduct. Don't you know where to go now? Acid. Must file. If you file it, it's easier to find. But can you find it? Can you have topic 3.1? Found it already. So we're just recapping last week. Now, I know we started a little bit on this, but I want to redo it so we all continue to be comfortable with balancing equation. Many of you are learning balancing equation now in school. I mean, some schools will teach balancing first. I think who was it? Harris or who? Kelly, I can't remember. But balance equation is something that you continually need to get good at. So myself take this opportunity. So we're learning acid reactions, but at the same time we're writing chemical formulas. Might be a bit difficult for Wenxin because she's new. So the rest of the class did crisscross for like 1 whole month already. So let me just break it down. First, you must memorize the reaction. You must know what plus what will result in what and what. So for example, the first one, if I use any acid on any base, I will get a salt. Later we'll revise how to figure out. Sometimes salt is a bit tricky, but water is water. Water is H2O, no other way. So we look at the example. Who can read me the chemical name of this guy? I mean, you can say Na2O, but if I wanted you to spell it in English, what would you call it? Huh? Not nitric. Na is tricky because we don't. Na is not the symbol. Clarice got it. The symbol is not the spelling. Na is sodium. You get used to it, okay? After a while. So sodium, Clarice, can you finish up? What do we call the whole thing? Sodium oxide. How did they get Na2O? The rest of the class should know. Wenxin, since you're new, just slowly look at it. Maybe you see you're still equivalent. So your school only just finished crisscross. Or haven't. Have you learned ionic bonds in school? Huh? Started. So have you done a bit of crisscross already? Okay, so let's just make sure we are all good at this. Those of you who are comfortable, continue to get more comfortable. Na must be Na plus, no other way. Did I memorize this? Where do I get this information if I don't memorize this? Okay. Would you know how to look at a periodic table and confirm that sodium is Na plus? When you don't know, just say don't know. Okay. Okay. Keith, explain. Why is it Na plus from the periodic table?
Lose one.
Because you know where my periodic table is. This first few pages. First few pages near the cover page. This one next behind you side. Yeah. So sodium is group 1. Can you see where? Can you find Na? It's on the left side. Yeah. Can you read this group? So you know that sodium is group 1. Sodium is in group 1. Right? Everything in group 1 has one extra electron. So they will lose it. When you lose the electron, you are plus. Everything in group 2 will become 2 plus because you want to lose 2. Right? So if I look at the periodic table, I already know Na is plus. Oxygen, Wenxuan tell me is group 1. Just find oxygen and then try to read the Roman letters on top. Where's oxygen? It's what? 3, 4, 5, 6. Right, group 6. Oxygen is group 6. You need to know the charge. Basically, charge is just look at oxygen, see how far oxygen is away from A. So 6 number 6 external electron, you need how many more? 2 more. So to gain 2 electrons, you will become 2 minus. This is the first working. Okay, I'm sorry guys, I'm doing this because you all had this already, but it shouldn't happen. So just make sure everybody's on the same page. This is the working to work out an Na2O. Then you say you learn crisscross, so you know the 2 comes here. The 1 goes here. Right? So the 1 goes here. So the first working that you come up with is 2 come here, become 2, 1 go here, become 1. It's Na, no more charges already. So 2O1. But we don't write the 1. 1 no need to write 1. So it's Na2O. We use the same logic because sulfuric acid is a bit harder. Okay, Wenxuan, especially you, the rest have done this already, but still revise. H plus, just memorize, it's always H plus. Anyway, because hydrogen is group 1. It makes sense that you lose 1 electron to H plus. Sulfate is SO4 2 minus. Where do I get this information from? Who will tell me in exam sulfate is SO4 2 minus? Nobody. So my point is, you don't memorize this, but you're literally dead man. Right? That's why in my notes, I also printed this for you. Sulfate is SO4 with a 2 minus charge. Must memorize one. If you don't memorize, you literally cannot carry on already. Now, so H plus is known, SO4 2 minus is memorized. So same thing, I put the 2 to the bottom. I put this, what number is this function? 1, I put it here. Okay, so this is called the crisscross. So the result is H2SO4. Do I need to bracket 1 or something? No need, because 1 is just 1. So that's the answer, H2SO4. So the groundwork is really quite hard. To know that Na2O is this and sulfuric acid is this is really not easy. Then we work on the, so I erase the working. So the outcome of this reaction is I get water. So a lot of times we write water first. H2O, no big deal. But you think about it, H2O came from where? H2O came from the H plus and the O2 minus here. Okay, no need to write this down. I just need you to roughly know because each compound has 2 ions. So I can see Na plus and O2 minus, this H plus and SO4 2 minus. If I use red color, who can contribute to H2O? Do you think it's sodium? Do you think sodium became part of H2O? Clearly not. So if sodium wasn't part of it, then I must take his partner, I must be the other guy. O2 minus must have been part of the H2O. Then same thing, I look at my second compound, H plus and SO4 2 minus. Obviously, who contributed to H2O? Who? Where got H2O? H plus. I'm not doing any balancing, I'm just checking which species went to where. So knowing that the red color ion, I mean the red highlighting here, these 2 went on to contribute to making water. This salt, originally you still don't imagine we know it's a salt, but we don't know what it is. What kind of salt? Using some common sense, who must have contributed to the salt? Who have I not highlighted? The what and the what? Sorry? Na plus and SO4 2 minus must become my salt. Then you can do working or you can use your brain, use mental sum. How do I crisscross Na plus and SO4 2 minus? And can I write Na plus and SO4 2 minus, or can I write SO4 2 minus and Na plus? Is there a rule? All ionic compounds must start with cation or anion. You hear sodium chloride or chloride sodium. So that already helps us with the rule already. All ionic compounds are named starting with cation. So if you are a beginner, you can do slowly. You can write the cation, then the anion. Na plus, then write SO4 2 minus. You cannot write SO4 2 minus Na plus, wrong already. Okay, must be like that. Then you crisscross this lah. The final answer is the salt is Na2SO4. Yeah. You crisscross it. So it's all about crisscross. Follow? Then, okay, all this working is messy lah. Then my final outcome is this. I need to check for balancing. What's balancing? I need to make sure all the atoms on the left matches all the atoms on the right. How many sodiums can I count? Yeah. 2. How many sodiums should I count here? Also 2. Can I see 2? Can. How many hydrogens can I see on the left side? Total. Right side must have. Is it fine? So far so good. How many sulfur? How many S can I see? On the left. 1. It's 1, it's not 4. Some people think that the 4, no, the 4 is only 4. So it's 1 sulfur. Right side. Hey, how come I got bracket? I just don't need bracket. Yeah, silly, only bracket. But doesn't matter. Okay. But the idea is it's still 1 sulfur lah. Now I can count that. Oxygen. Oxygen a bit harder to count. Who can count me the number of oxygens on the left? 5 oxygens. You see? This is 1. This is another 4 of them. How many oxygens am I expecting on the right? Do I have 5? Yeah, so this is balance lah. Balance equation is done. Now, state symbol is a bit higher level. Some of you are not expected to know this yet. State symbol is the state that they come in. Who told me? Okay, this one is guaranteed. What is AQ? Aqueous means what? Dissolved in water already. Can I write anything else for this? All acids must be aqueous. So just no brainer. This little L means it is what state? Liquid. Can it be anything else? No. It must be liquid. Water is liquid unless I heat it up. Then it's steam. Then it's gas lah, G. If I freeze it, if I run this experiment in the freezing room, then the water that comes out is solid ice. But naturally, you don't expect that now. You're expecting a normal reaction in the normal room temperature. So I naturally can put L here. Now, this one S. Who told me this is solid? How did I know it's solid? Nobody told me, ma. How? It's so easy to accidentally write aqueous if I didn't know what I'm doing. So my question is, how come? Don't know. Okay, because alkalines, there are 4 that you memorize what alkaline. Now, this is the base, but this is not alkaline. Base, then you can write AQ. Alkaline can write AQ. Bases are all solid. Then the last one, this one you haven't learned. This one next chapter. Why is sodium sulfate AQ? I will teach you next chapter. So this one I'll give it to you. Okay? Are you okay with this first example? I'll make another one. How about this? We make together. Can I have one volunteer give me another base? So my first example, I use a sodium pair up with an oxide. Okay, can somebody creatively give me a base? That means you anyhow take a metal, you crisscross with any oxide hydrogen. It's the same as what we did last week. Who can try? Hey, easy, come on. FeO. Keith wanted an iron oxide. He wants an FeO. Then my question is this valid? Is this an okay base? Yes. How do we know it's okay? It's made of a metal, crisscross with an oxide. And who already can tell? Keith knows that, but who else knows his iron what charge? His Fe is what charge? How come it's 2? It is 2. But how did he and Jingwen know it's 2? You crisscross the O2, the 2 disappear. 2 and 2 cancel. Yeah. So we already know. That means even Keith didn't say it. We already know it came from Fe2 plus and O2 minus, which later will be useful. Now, I want somebody to give me an acid, but I don't want sulfuric acid. Who can, out of your memory, give me an acid now? Wrong, never mind.
NH4.
NH4. No. Oh, good try. Okay, who can give me another acid? We only learn 3. This is H2SO4 is the harder one. The other 2 easy. The easiest is NaOH is alcohol. We are doing acid. Right? You can look at our first page. Acid there are only 3.
HNO3.
HNO3. So Clarice wanted HNO3. Who knows what is the name of this acid? All memorized one. I told you there are only 3 acids to memorize. This is one of them. Nitric acid. And they came from the crisscross of what and what? H plus and NO3 minus. Later will be useful. Okay, now, based on our technique just now, I write down the water first so can. Water can come first, doesn't matter, liquid. Now, same thing, you ask, who can, don't give me the answer, who can tell me the ions that I must put in the salt? Which ion haven't used yet, must use that? Oh, okay, out of this, which ion have I used? Which ion must I use next? Fe2 plus. So I can do some working here first. Go here and write Fe2 plus. Stand by first. Here. Which ion was used already to make the water? Which ion must I use next?
NO3 minus.
Okay, who can? Okay, Jingwen keep answer a lot today. Clarice also next. Somebody else. Tell me the crisscross of these 2. That's the answer already. So that's how we work out the salt. You always work backwards. Okay, you see what you haven't used and use. Everything must be used now. Eventually. Who can tell me the crisscross? Oh, sorry, Kelly said HCl just now. I didn't see. Sorry, I didn't pay attention to the chat. Later I will. Okay. Who can give me the crisscross of this final answer?
Fe.
Fe.
NO3 too.
NO3 with the bracket. I hope you meant with the bracket. Okay, correct. Now, state symbols, as I said, some you must know, some you will eventually learn. Nitric acid, you must know the state. Confirm as aqueous. FeO, who wants to make a brave guess? To guess it, whether it's solid, liquid gas, or AQ. Should be solid because it's not an alkaline. Okay, then Fe, iron 2 nitrate, you don't know yet. Next chapter you will learn, so I'll tell you it's AQ. This is neutralization of iron 2 oxide and nitric acid. Next, you can erase that. Everybody make me one example.
So if it's not non-alkali, it's solid.
Most bases are solid. Later when we teach alkaline, I will teach you to memorize 4 alkalines. 4 alkalines are SPCA: sodium, potassium, calcium, and ammonium hydroxide. Only 4 alkalines. Everything else you just take it as solid. All bases, 90% of bases are solid. Only 4 alkalines. Okay. I'll erase this. I want everybody to make one more example. You can write in the paper, and if you need rough paper, write anywhere. But you will keep practicing this. You need to be very good at making formulas and equations. Come out with a new base, use another acid. You want to challenge it. Actually, sulfuric acid quite hard to use. You can use another time, H2SO4. Make your own water, make your own final salt. Use the same technique. Okay? All the state symbol, try your best. Wrong, never mind. Everybody make one. I want to see everybody's work. You will WhatsApp to me. Okay, I see one answer from Jingwen. Lithium hydroxide and hydrochloric acid. Totally correct. Okay, if you want to try for state symbols, no need lah. Lithium hydroxide is a bit out of syllabus, but HCl is what state? For Jingwen's answer. Then water. Water is not equal. Water aqueous means mixed with water. So water is all liquid. Okay, there's no aqueous water. Then lithium chloride, you haven't learned it is aqueous. But then you can just fill it in for fun. Okay. I just need everybody's attempt to make your own neutralization equation. Take anything.
This choice is Li.
No. First, lithium is not Li2 plus. Lithium is group 1.
Then
Right? Lithium is group 1. Last time you crisscross Li plus and O2 minus, right? It's Li plus. I mean, you get LiO2 because the 2 from the oxygen came down. Lithium is always Li plus, and this one you shouldn't copy from O. You should just look at the periodic table. Lithium is group 1. Right, just now you answer the question. Group 1 all plus 1. These are good options. Okay, to make the water first. First, water is always produced neutralization. Then you ask yourself, which ion you can highlight, like Jingwen did, she highlighted the unused ions. So who is waiting to be used? K or OH minus? K plus or OH minus? K plus, right? And who haven't used it? H plus or Cl minus? To make water, you need H2O. So the Cl minus values. So your final product is K plus crisscross with Cl minus. You can do it mentally or working. You can write by the side of your head. We will cover that today for sure. As of today, I will cover all of acid and base already, and then y'all can do some difficult questions.
I don't understand. Base plus acid gives you salt.
And water. This is a standard reaction that you memorize first. Then you can figure out what to go in.
Then what? Then salt is what though?
Salt is just typically the crisscross of ions. So, generally what's the definition of salt is a metal something. Like in my example, in my notes, this is the salt. This is the salt, this is a sulfate salt. To fully call it is a sodium sulfate salt. This is a salt. So salt is just generally, you don't really think too much about it. Salt, just think of it as ionic compound. It's ionic compound of whoever is left. So in this case, I need to use the sodium and sulfate to make this salt. And then in every example, the salt will change, but the salt is just always metal something, metal something. In this case, sodium sulfate. Jingwen's case, lithium chloride. For Keith's working, lithium sulfate. Good. And then for Wenjuan in the class, she's doing K plus and Cl minus. Okay, Kelly is working on a calcium chloride. Very good, very good. And your state symbols happen to be all correct also. Very good. Okay, state symbols, y'all won't be tested, so I'm just giving you for fun in advance first. So Clarice, are you feeling okay? Better to continue? Who else? Xianghui? I'm spending a bit longer here because later it will be all the same. The formation of all the salt is the same technique. Just grab the ions you haven't used. Okay, so soon later it become easier and easier. Still waiting for Xianghui and Clarice. Once you get it, we can move on. The rest y'all can memorize equation 1, which if you have done already, you can start memorizing equation 2. Later I'll explain. And equation 1 we just finished. Equation 2 is another type of acid reaction. There are 3. So there are three versions of acidic reaction that you have to eventually fully memorize. So later, soon we'll go to metals. Xiang Hui, correct. Clarice, wow, very challenging crisscross, but you look good. It looks good. Okay, Clarice tried something difficult, good for you. Okay, all done already. Now, acids also like to react with metals. Okay, acid also like to react metals, which means all the metals on the left hand side of the will react with acid, except there's a small exception you'll learn further in Sec 4. Then metals must be reactive enough. Some metals are not reactive enough. Who can guess what metals are very unreactive? Think of your sports day or Olympics. The metals they use must be unreactive. Reactive means what? You bring home, the rain comes and disappear already. So what metals are very unreactive? You can copy this unreactive metals. We have memorized three first, which are very easy to memorize. Just think of Olympic. You don't watch Olympic. You play sports.
Gold,
Yes.
bronze,
Silver. Okay, bronze is what we call in Olympic, but bronze is actually an alloy. That means you combine something with something. It's actually copper. Okay. These three are unreactive metals. You can write down first. In very rare cases, they will trick you. That means they ask you to react silver with acid. Then your answer should be nothing happens. They ask you to react gold with sulfuric acid. Answer is nothing happens. Okay. Very rarely tested in Sec 3. But just write down for future sake also, it's good for. So that's why we say that only metals that are more reactive than copper will react with acid. It's a very easy reaction. See, we look at my example. I chose magnesium. A literal piece of metal, obviously the state is solid. Have you ever seen a watery metal? I don't think so. A gaseous metal, impossible. Right, must be solid. Metals are always solid, except one. You all know there's only one liquid metal in the world. Liquid as in, not in the world, in room temperature, all metals are solid except mercury. Mercury is the one in the olden days thermometer. You know, in the past, we put mercury in the thermometer to check the temperature. You know why we don't do it now anymore?
Because the glass break.
If the glass break, mercury is poisonous, so we don't touch that. So now it's all electronic. Okay. But anyway, solid. Acid, I happen to choose what kind of acid? Who can tell me this? Nitric acid. Must memorize that. It's the crisscross of H plus and
NO3 minus.
very good. Now, the first important thing to come up with is hydrogen gas. Hydrogen gas must be formed. Okay, memorize this. Then the rest is the salt. Also, when you do the salt, it's the same thing. You ask yourself who haven't used it, right? So since I told you, I get hydrogen gas, it is the H plus that became the hydrogen gas. So who have I not used? Very obvious already. Mg and nitrate. You crisscross magnesium and nitrate, you get magnesium nitrate. Mg bracket NO32. It's quite doable. After you understand how salts are generally produced, it's the same for every question. You just grab the ion 7, use it. Okay. So importantly is you must know hydrogen gonna use already. So the hydrogen won't join the salt. Then whoever, in this case, is magnesium and nitrate crisscross. Okay. Everybody make an example. Same thing. Everybody make your own example. Sorry, can I say stop you a bit? Hydrogen must be gas. I mean, we all know hydrogen is gas. So bracket gas. Then the metal must be solid. Then usually the acid and salts are equals. You haven't learned enough yet, but just generally all equals. Okay, make your own example. Choose your own favorite metal. Don't need to be too adventurous. Just choose group 1 and group 2. Because if you choose some weird transition metals, manganese, all that, you also don't know what the charge are. But group 1, group 2, we already know the charge. Okay, choose your metal, choose your acid. Know that the product must have hydrogen. Then the other guy, the salt just leftovers crisscross. Then balance, mass balance. Okay, appreciate your speed, but Ca2 plus is not a metal, it's an ion. You look at my example, we started with a magnesium, a literal piece of magnesium, right? But you're working, you started with a Ca2 plus ion.
Oh, so
It's just a Ca. I know this is a common mistake, so I'm glad you made this. Jingwen, can you put a plus in between? These are two products, H2 and your calcium sulfate. But it looks like one compound now. It shouldn't be one compound. H2 is its own gas. Then this calcium sulfate is happens to be solid. It happens to be solid by chance, but you wouldn't have learned it. You have bracket solid now. Your calcium sulfate. But you haven't learned yet, so you won't know. Next chapter we'll learn why. Clarice use a beryllium solid. Sulfuric acid. Beryllium is group 2, yeah? Good, got balance or not? Got balance, can. All got balance, Kelly, balancing looks good. Keith, fix it already?
but it's not bad.
Calcium chloride is correct. You have one calcium. Correct already, it's balanced already. How is it not balanced? 2 HCl means 2 hydrogens in total and 2 chlorines in total. Which I can see on your right hand side. It's correct already.
But
No. The crisscross, you cannot just copy Ca and Cl and say it's calcium chloride is Ca2 plus, crisscross is Cl minus. So the origin is Ca. The final product is calcium chloride, which is Ca2 plus and Cl minus. So you're right. How come a little 2 here? So metals are just, but metals are not magnesium is just magnesium. So let's take away the little 2. And this is okay. This is okay. Yeah, balance already. It's correct. Good. All correct. Okay. Xianghui, I haven't seen yours. Let me check. Xianghui, don't write equal sign. Okay. Never ever write equal sign in between your equation. Must be arrow. Okay. I know it feels the same. I also feel that it's the same, but they will take away your marks. Xiang Hui still got one mistake. You never crisscross your sort properly. Xiang Hui, can you unmute and discuss with me what happened?
Yeah.
You know why? What's your correct sort? Your sort that is wrong, but what is the correct one?
It's not. L.
No, your salt, your sodium sulfate.
Oh, wait. Yeah.
What is wrong and what should be corrected? Okay, Xiang Hui is trying to figure out what is sodium sulfate. Those of you who want to try, go and work out what is the sodium sulfate. Xiang Hui, I don't think you did a working. I don't think you tried to work out sodium sulfate. I think what you did was, okay, I'm not shaming him, but I just write his answer out to show you. He think that sodium sulfate is like that. Right? And I told him it's wrong. So who knows why this is wrong and what should be corrected? Anybody can try. So you go back to the basic working. What is the sodium ion? Xiang Hui, what is the sodium ion? Shouldn't take so long, but we've done so many sodiums already.
Sodium it's.
I mean, you're using sodium, so you must have been looking at sodium in the periodic table earlier.
Yeah.
What is sodium ion?
SO2.
Sodium. What's the sodium ion? Na plus. Are you okay now?
Yeah.
Wait, how come you go SO2? What are you talking about? Sodium. Sodium. What is the sodium ion? Tell me.
SO plus.
SO plus.
Hold on.
Do I need to show you the periodic table?
No, I have it.
Xiang Hui, where is sodium? Look at my screen.
You're not fine.
You did where?
Oh, sodium is in.
I mean, you're using it like the whole time.
Okay,
How come? I mean, okay, I'm not scolding you, but how did you work with sodium without knowing where it is?
No, I lost. No, I found it just now, but like now.
Okay, a bit shocking. I'm not scolding you. I just don't know. I mean, usually what we do is you find it first, then you choose to use it, then you use it, right? And then you wrote it so many times, but apparently you didn't know what it was. Now you know what sodium is. What is the charge?
Plus.
Na plus. Then sulfate must memorize, right? Can you see your mistake already? What's the answer? What's your correct sort?
The correct sort is SO4 minus.
Sorry, say again.
SO4 minus.
SO4 minus is a salt.
Yeah.
You never crisscross for me. I wrote it. It's all on the screen already.
N2SO4.
Yes. This is the correct sort. That's why you have to do this and then do your balancing.
Yeah.
Okay, Xiang Hui, can you work on it on your own?
Yeah.
Make it correct. So you must balance and change your equal sign to arrow. Now, guys, one thing to note, this reaction produces hydrogen. You read the little box bracket. It is an effervescence. What is an effervescence? Here before? Okay, effervescence is not precipitation. Effervescence is the gas release. It's just a nicer way to say a gas release. I mean, it is a gas release, but we don't say gas release, we say effervescence. So in real life, when you do this in the lab, you see bubbles. Bubbles. What is effervescence? Your mother got make you drink the vitamin C tablet. Your siphon, the big round one. You put it in the water, what do you see? Effervescence, that's effervescence. So bubbles in water is effervescence. Okay? So H2 is also an effervescence. that extinguishes a lighted splint with a pop here before. No? You take a stick that is flaming. This is a stick that has fire. You hold it above the effervescence. I mean, it's just bubbles. So you see, then inside got bubbles. The bubbles, once it reach the air here, cannot see already, but it's still flying up. What is these bubbles made of? H2. H2, do you know that it's explosive or not? Can write down. H2 is explosive. So this explosive gas, imagine it's like gasoline, it's like petrol. It fly up and touch the flame. What happens? Imagine your gas kerosene leak like home leaking, then got fire, small spark. What happens? Explosion. Right? Flammable gas touching a fire. It will explode. This is an explosion, so this will explode. The fire will explode. Pop. That's why it will be gone. Sound out, and no more, but you'll hear a pop. The pop is due to the explosion. So hydrogen gas is explosive. How come I'm telling you this? Because when there's effervescence, you see bubbles. Can you guarantee it's hydrogen? Would you know it's hydrogen? No, until you take a little flame, put it over the top of the test tube and see whether it explodes or not. If the flame explodes, then you confirm that it is hydrogen. If it is hydrogen, then you confirm that you did have a metal acid reaction. So you can move backwards. Because the flame popped, I know there was hydrogen gas. Because there was hydrogen gas, I know it was a metal acid reaction. So you already can prove the identity. That's the question. You are proving the identity of the first substance, original. You don't know what is it? Is it metal? You do this test. Now, last one. This is a metal carbonate. Reaction with metal carbonate. Metal carbonates. By now, the older students, I'm hopeful that you all memorize carbonate. Wenxuan maybe haven't. If you have, you can tell me. Who knows what's a carbonate? Must memorize it.
CO3
Very good. CO3 minus. Metal, anything. Can be magnesium, sodium, no need to copy that. Potassium, iron, beryllium, francium. You do whatever you want. Okay? All these metals not important. This is important. So metal carbonate, which you already memorized the carbonate, you must form a carbonate. Look at my example. Who can read me this guy? Potassium carbonate. So if you cannot read, then slowly familiarize what is a K. You can go to a periodic table. Sometimes a teacher made me memorize the first 20 elements of the periodic table. So it is the crisscross of K what? Xiang Hui, tell me.
Sorry.
Hmm?
Crisscross of what?
Yeah, potassium carbonate came from what and what?
Potassium carbonate.
Obviously came from potassium and carbonate,
Yeah.
Right? What are the ions?
Oh. Potassium is wait. Where's potassium?
Somewhere I find that you are underperforming today. Please try to back up now.
Oh. Potassium is minus. K minus.
Potassium is group what?
Wait, no, sorry. Sorry. Potassium is K plus.
Wenxuan, would you agree potassium is K plus? Xiang Hui is saying potassium is K plus. Agree? Okay. Xiang Hui again, what is carbonate?
CO3.
That's it?
Carbonate. Yeah.
Like that can crisscross or not? I don't know how to crisscross like that.
Oh.
Can crisscross, man? This is not even an ion. CO3 not even an ion. No charge, how to crisscross. And we just wrote this on the screen. Xiang Hui, we just wrote what a carbonate. I literally said, I hope you have memorized this already. And I wrote it on the screen. Then I erased it. Then now you don't know what it is.
Oh, CO2 minus.
CO2 minus. Is it?
No, the 2 is on top.
So CO2 minus.
Yeah.
Is it? Where do you get this information from?
Because if it's crisscross with K, then it become
No. I told y'all must memorize the 5 polyatomic ions: carbonate, sulfate, nitrate, hydroxide, and ammonium. Have you memorized it?
Yeah.
I mean, obviously no lah, haven't lah, but it's okay. Can you look for it? Do you know where to look for it?
I wrote it down.
Then find it and tell me, because it's all wrong. Everything on my screen is wrong.
Okay.
I mean, you have my file. I always tell you where to find it, man. It's the first few pages. I said I printed a special periodic table where at the bottom I also typed out all the weird ions that you must memorize. What do you know what I'm talking about?
Yeah.
Then why are we having so much trouble? Unless you lost the profile. I don't know. I mean, what's wrong? You have it already? What is it?
CO32 minus.
Yes. Even if we forgot to memorize this, if you are more experienced, guys, if you look at K2CO3, you also can guess what it came from. The 2 just bring back, then K is 1 plus. With a bit of experience, you all will know because it's group 1. So anyway, this is potassium carbonate. So when I see this question, a typical question for a test could be they just give it like that. Then they ask you what products it forms. So of course you must memorize. Carbonate got 3 products: salt, water, carbon dioxide. Now, water and carbon dioxide is given. Water has to be H2O, carbon dioxide has to be CO2. So let's see how we get the answers. I'm assuming we didn't have any answer. I write out the ions so that later I can know who to use. I write it out again. HCl is H plus and Cl minus. I hope nobody cannot do this. Now, I memorized that it will form water. I memorized it will form carbon dioxide. And I memorized that it will form a salt, which is a bit harder to form. Because now got many things, you see. Who must contribute to water? Yeah, I mean, ion 1, 2, 3, and 4. Who must have been definitely involved in forming water? 1, 2, 3, or 4, or a few?
2 and 3.
Very good, 2 and 3. But even if you didn't know 2 and 3, knowing that it's 3 is good enough. H, got H, I mean, yeah lah, you are smart because you know the carbon dioxide also give a bit of oxygen, you're right. Okay, but even if you didn't know, it's okay. So this one kind of settled. If you thought that, oh yes, you're right, this one used already. Good. This one, no brainer. Who must have became carbon dioxide? Out of the 4 ions, which ion has the ingredient to make carbon dioxide? Only 2. Right? So now we know the salt already. You can see the salt. Who can read me the salt already?
Potassium chloride.
Potassium chloride is the answer. Right? So right? It feels a bit difficult, but you use the same thought process. You grab all the ions that you need, the leftover. Always only have 2 leftover. In this case, it's a K plus Cl minus. So the product is KCl. Who is lost? Tell me now. This is a little bit harder. Okay, Clarice, do you have questions?
So what's supposed to take the first one and the last one?
In this case, it happens to be K plus and Cl minus. But what I'm teaching you is to eliminate because I know the product must be water. And I know water can only come from 2 and 3. Do you agree? Because only they have the atoms that can potentially make water. Then I know another product is carbon dioxide. The only person that has C and O is carbonate. No other person really. Which means they are somehow occupied. That means this term, second and third guy, this 2 and 3 are somehow involved in my final product already. But who have I not used at all? I haven't seen the appearance of potassium. I haven't seen the appearance of chloride. So they must become the salt. Because if not, how to balance? Later to balance means the atoms must match. The number of metals from both sides must somehow eventually balance out. So it's a bit of elimination. You look through and see which ions must contribute to the final salt. The salt is always the last thing you try to put in. Can?
Yeah.
Who has questions?
Cannot use sulfuric acid because
Can.
don't have H.
Sulfuric acid is H2SO4 using
Oh.
sulfate. Okay. If no questions, you'll try one example. You will make your own carbonate, make your own acid. Okay. Okay, must speed up a bit. I'm trying to finish this until page 5 lah. One more page today. Then the rest must be homework. Slightly harder, but really not that difficult. Same logic. You use a cesium carbonate. Cesium is good one. Sulfuric acid. Then your salt is wrong. Cesium is good one, is it? Then your cesium sulfate is wrong. Right? You didn't crisscross. If it's 1, then the sulfate got 2. Like, where did the 2 go?
CS to SO4. Right.
I don't know. Yeah, you must make it correct. So Jingwen's magnesium carbonate, hydrochloric acid, give you magnesium chloride. Ayo, same problem. All of you making the same mistakes. Your salt is also wrong, Jingwen. Can you see your mistake? So some kids are too eager, you are too fast already. You never think of what is a magnesium ion, what is a chloride ion. Magnesium is what? Mg what? 2 plus. Chloride is? Keep checking, keep looking at the very table. Get used to it. Next time you memorize it. Cl is? Group 7, group 7, 1 electron away. Cl minus. Right, so your MgCl is not correct. Is it ready? And the balancing already correct. Yeah. Good because carbonate. Hey, why got so many trees? You're trying to balance it. No, balancing comes outside the number. Inside is during the crisscross. So barium carbonate is BaCO3. Because the 2 go down, the 2 also go down, the 2 cancel, so no more 2s. So barium carbonate is very low, it's BaCO3. Because carbonate is CO3, the CO3 is one piece of thing, it's a charge. So I'm going to break that tree also. Yeah. Plus HCl, barium chloride is correct. Okay, then try to balance this. So shouldn't have so many trees. So carbonate, 1 on the other side, 1 barium, 2 correct. This answer. If you solely count the atoms, they should be matching. So after you change, you must continue to balance them. Kelly, I see your stuff now. Is perfect. Xiang Hui, you still forget to cancel the 2-2 magnesium carbonate wrong straight away. Xiang Hui, you are not building very good habits because you have been making this same mistake a few weeks. Right? Magnesium carbonate, the 2 and 2, yes, you did crisscross, but you forgot to cancel. But generally, your approach is okay. That means generally your substances all correct, just that your magnesium correct wrong. So when you can change and balance, because you must have MgCl2, right? Yeah, automatically self-balance already. Okay, who else? Clarice, Hannah.
We are sending.
Okay. So Xiang Hui, you fix your mistake already. You must fix because I don't hear from you. I don't know whether you heard me. Or you can send again. There is lithium carbonate, correct? Nitric acid, correct? All good. Very good. Balancing also good. Yeah, all these can be balanced. All these reactions surely can balance. If you cannot balance, means something wrong. Maybe you crisscross wrongly. Okay, we're moving on. So a bit more. This is also an effervescence. Who still remember what is an effervescence? Gas release. So basically you observe it as if you look at it, you see bubbles. You see bubbles, eh? This bubble will turn lime water chalky. Lime water, right now, what is lime water? Calcium hydroxide. Lime water is calcium hydroxide. Not super required, but good to know. And it will turn lime water chalky. Chalky, the more professional way of thinking of chalky is what? Precipitate. Have you heard the word precipitate? Probably haven't. Haven't, right? Precipitate is another fancy name for solid. Really no big deal. It's just solids. Formation of solids, cloudy, chalky. It's as if you mix chalk and water. Just black solid, white solids. So this is the test. Let me see if I got bubbles already. I collect all the bubbles, pass it through calcium hydroxide. If I see white solids, then it must be CO2. If I don't see white solid, it must be something else. Okay, quickly we move to the last page of today. Now, we already talked about most of them, so I'm going to speed through. Bases will always react with acids to give salt and water. We kind of did a lot of that already. Bases are all metal hydroxides and most metal oxides. So as I keep saying, it's very easy to be a base. Look at my Venn diagram. The base is a big word. What is a base? Metal oxides, hydroxide are all base. Look at my weird examples. Iron oxide, magnesium hydroxide, copper oxide, silver hydroxide. All of these are bases. But there's a special category, there's a small subset, that means a small piece of the whole world of bases that we call alkaline. Why are they so special that we give them a special name called alkaline? Because alkalines are bases. They are part of the family. It's just that not only are they base, they are also soluble. The fact that they are soluble earn them the special name. So if I have a soluble base, I call it alkaline. Is it a base? Yes. Yes. Right. And in O level, you can memorize 4 alkalines. I like to call them SPCA, which is the place you go and adopt rabbits and dogs, right? SPCA. Sodium, potassium, calcium, ammonium. Just memorize. Okay. Out of SPCA, it's good to know that calcium hydroxide is the weakest alkaline. It's all in the notes. But this is all little extra information. The more you know, the better. But hardly tested. Calcium hydroxide is the only weak alkaline in this 4. So SPA are very strong. Strong meaning why strong? Because they can, what's the word? Fully dissociate in water. So you see a lot of things keep recurring, a lot of concepts we need to keep thinking through them. Now, ammonium hydroxide takes a bit of practice to crisscross. You can write down this working. Ammonium is memorized, NH4+, hydroxide is memorized, OH-. The numerical value is 1 and 1. You crisscross that 1, Just write them next to each other. It's the 1 and 1, no need to write. This is ammonium hydroxide. The rest quite okay lah. Sodium hydroxide, KOH, Ca bracket OH2, all quite easy. And just now this lime water we already talked about in 1 page ago. So it's just ammonium hydroxide. Sometimes I feel a little bit hard to crisscross or memorize. Okay, ammonium hydroxide has a simple name. We just call it aqueous ammonia. Also can. No, it's aqueous ammonia. Aqueous ammonia. They're referring to the same thing, referring to the same thing. Okay, SPCA. Quickly go through the properties. Very easy. Bitter. What do you think of alkaline? You already should think of your detergent and soap. I know you're not supposed to taste it, but you must have tasted it before. Your soaps, when you shower accidentally, it's a bit bitter. Right? Soaps are bitter. Of course, soaps are soapy. So it's quite easy to remember alkaline property. Just think of soap. Okay? If acid's color is dangerous red, alkaline's color is blue, like clean. You know, blue gives you a feeling of cleanliness, uniform, like FPCC, all the clean stuff. Blue is clean, just like what your soap is meant to do, make things clean. So it's good to associate alkaline with blue. They make OH minus ions. We said it a lot already. It is the dissociation that forms the OH minus that makes it aqueous, makes it an alkaline. Also an electrical conductor for the same exact reason as acid, because they have free what?
Ions.
Ion. Yeah. They don't have free ions and electrons. Right. To conduct electricity, you need free ions or electrons. You cannot have, nobody has both at the same time. So what do they have? Free ions. Free electrons have or not? Don't have. Do they have electrons? Do alkalines have electrons? Obviously. Everything has electrons. Does the phone have electrons? Does my head have electrons? Everything has electrons. But does my head have free electrons? Probably not. Okay? And so it is the free ions. So never ever say mobile ions and electrons. You answer that in any question, 0. Because it doesn't make sense anymore. It's either or. 其中一个, right? Now, Jingwen said she struggled a bit with this. So let's see. First equation, usually I don't teach. Why? How come no need to teach? How come no need to teach, but it's in my notes and it's important? The first type of alkaline reaction is when an alkaline reacts with an acid. How come no need to teach? Huh? Because we literally learned it for 20 minutes just now. Because if acid will react with base, acid will react with alkaline the same way, because alkalines are bases. Right? So the characteristics of acid is it loves to react with alkalines and bases. Then vice versa, if I'm alkaline, I love acid. If I'm acid, I love alkaline. So the way acid reacts with alkaline isn't it the same as the way alkaline reacts with acid? It's literally the same. Salt and water, no need to teach. Everything same. I won't even ask you to do an example. Easy, really no need, right? It's the same, same. So same as last page. Same as last page. No need to learn this. I mean, you can go home and make your own examples, but we're not wasting time. Okay? Now, 2 onwards is difficult. 2 onwards is difficult. Alkalines love to react with ammonium salt. That means a salt. Just now I said what is a salt. Salt is just an ionic compound. And ammonium, I'm going to ask Xiang Hui to tell me, because just now he was struggling with ions. Xiang Hui, what is ammonium?
Ammonium is NH3, supposed to be, right?
That's ammonia. Ammonia is NH3. I'm asking ammonium, which is one of the 5 ions I keep telling you to memorize.
NH4.
NH4 is not an ion. 听起来, you once you hear, you know it's not an ion because you didn't tell me a charge. So no charge, no ions. Ions must have charge. You're on the right page already, so Wenxuan should be seeing it now. What's an ammonium?
NH4 plus.
Yes, you must tell me the plus. Don't be lazy, okay? So basically, an ammonium salt is an NH4 plus ionic compound. So I can crisscross ammonium with any anion. In my example, what did I use? Somewhere read me my example. My example. What is this?
The ammonium salt.
Ammonium what?
Nitrate.
Very good. Okay, improvement. Okay, it came from NH4 plus, which is memorized, and NO3 minus, which is memorized. Okay, Xiang Hui again. This is my alkaline calcium hydroxide. What did it come from? It's printed earlier on top also, but I want you to tell me.
Calcium.
which is,
What do you mean?
do I just write Ca?
Must write the ion.
I want to ask you what ions it came from.
Ca2 plus.
Very good. Tell me again, what is the other ion that you came from?
There's another one for calcium.
No. Calcium hydroxide is cation anion, must be 2 ions. Must be one positive, one negative ion. What is the negative ion?
Oh, the negative is
It's the same page. It's the same page. Every ion I asked you today came from the same page. You have to memorize it. It's been a month already. You all should memorize already. I'm not picking on you, it's just that you keep getting it wrong.
oh Ca minus.
Wow, I'm gonna die. Somebody else. Always minus. Xianghui, are you okay now?
Oh yeah. I thought you were asking for calcium.
You just gave me calcium. I'm asking the anion, right?
Yeah.
Okay, never mind. So this, you must first identify that this is an ammonium salt. Is it okay that y'all can see this as an ammonium ionic compound? Because you must know what it is, then you know what it will become. And then this is an alkaline. How do I know this is an alkaline? Memorize. How to memorize? SPCA. Okay, without looking at notes, can you tell me what are the 4 alkalines? Just read to me. If you memorize SPCA, you're kind of there already. Sodium what? Sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. So I'm using the third guy, the C guy. Right? This is an ammonium salt and alkaline reaction. So then you memorize some more. You memorize that it gives you water, which is quite a standard. You realize a lot of things give water. Ammonia gas, memorize as NH3. The salt, same technique. You use whatever you haven't used. So you see, this one will give me H2O and NH3, memorize already. Then I ask myself, who can contribute to H2O? I use dark blue to highlight. So who can contribute to H2O using my 4 ions here? Roughly. Yeah? The nitrogen. This is nitrate, got nitrogen inside. Which ion must be transformed into H2O? The 4th guy, hydroxide. Okay, which ion will, obviously not very obvious, who helped me get my ammonia? First, second, third, fourth. First, very obvious. Can you all guess the salt already? Yeah, these are the salts. Who can read me the salt? Calcium nitrate. Can I say nitrate calcium? It looks like nitrate from the screen. It looks like nitrate calcium. If you write your exam, calcium nitrate calcium 0, because the first rule is cation first. So, sorry, Xianghui, not picking on you. Tell me the chemical formula for the salt. They already said calcium nitrate already. You just need to crisscross carefully.
CaNO3, Ca bracket NO 3,2.
Is this what you're trying to say?
No.
Very good. This is the hardest, in my opinion. This equation is the hardest. This reaction, alkaline plus ammonium salt, is the hardest. Of course, I haven't balanced yet. But I think self-balance. Yeah. Haven't. It's not self-balance. I didn't balance properly. Sorry. My notes didn't balance it properly. Let's just make it better. Okay. Who can quickly balance and tell me? I'll go and improve my notes, but who can help me balance this now? Y'all can try it, wrong, never mind. But my notes are not, sorry, shouldn't have mistakes here. Okay, how do I know it was not balanced? Because for me, quite obvious. My right side got 2 nitrates, my left side only got 1 nitrate. Can see it? Here got 2 nitrates. So I must make it fair. I must put 2 here. Balancing always put outside. Put it in front. I must put a 2 here to make the nitrate balance. But once I balance nitrate, which one did I mess up? I messed up the ammonia. Right? Because I accidentally doubled the ammonium. So what must I modify some more? ammonia. Yeah, ammonia gas, double it. Then quickly check my calcium. Calcium looks okay already. Then just quickly check my H2O, see whether the numbers work out. At this point, I can just count the O's, save time. Still not balanced. 6. Because my left hand side now got 6, 7, 8 O's. So I think I must double this. That's the answer. Okay, I'm just showing you some quick way. With experience, you can do this. Okay. And sorry, please help me balance my notes as well. Then if you want to, for fun, check the H's, because I didn't check H's. But if you check let's do the H's. How many total H's on my left? Who can count for me? How many H's are now in my left side? H, not 6. I got 2 ammonium, it's already 8.
Oh,
What do you mean?
is
10. H. 10 H. How many H's on the right? Should be 10. If it's not 10, I'm wrong. Is it 10? Yes, because 2 waters is 2 H2, which is 4. 2 ammonias, 2 times 3, 6, so it's 10 H's. So I'm okay. So this balancing is correct. Okay, we have 3 minutes left. How about this? Everybody make your own ammonium alkaline reaction. Finish it and we call it a day.
ammonium salts can only be NH4, NO3.
Ammonium salt. No, ammonium something. Ammonium, you can use chloride, bromide, anything. You're happy, anything. Yeah, so don't have to use ammonium nitrate. I happen to use ammonium nitrate, that's all. Who's that? You can, but let's still wrapping up. If you have something, go ahead and send it to me. This is the hardest part. Next week, I'll take 1 more lesson to complete what you need to know. So don't worry. Then by next week, we'll have finished acid and base already. So I think good enough if we master ammonium. As I said, this ammonium reaction is the hardest to learn because there are a lot of ions, a lot of polyatomic ions. In my example, I put nitrate, I put ammonium, I put hydroxide. So definitely not easy. Keith has something. You use ammonium chloride plus potassium hydroxide. Excellent. Good, very good. And this is simple, so everything 1:1, no need to balance. Okay, you can back up. Okay, well done. No homework. Yes. Okay, those AMAP students, I mean, it's about time already lah. So if you are still trying to finish up, you can take your time finish. I'm gonna let the AMF students come in. Those who are online, if you get it done first, then I give you a 1 minute break. Okay, go. The rest, Keith can go. I'll help with doing first. Bye. You're using which one? Using ammonium carbonate. Never crystal chloride. The two from carbonate goes to attach to ammonium. So NH4 still bracket, holding bracket, holding bracket. Then the carbonate is the recipient of the one. So that's copy of CO3. That's it. This is ammonium carbonate. Good. We're also using ammonium carbonate. Also good. Where is your ammonium carbonate? I mean, this is the working one. No, you crisscross already. These two went down, so it's bracket two. From the top chart. Then these two is another on top. Went down to the bottom right. So ammonium carbonate plus calcium hydroxide. Yeah. So you're trying to do calcium carbonate. Yeah. Right. Because calcium surely have it. Carbonate also have it. And have a balance for it, so you can balance it first. Yeah, for alkaline to choose strong, so you don't have to keep using it. You can use it. So keep using it for KOH, but up to you. You can use mine. The example I used was 100%. Is this guy? But you could use any of it. It will be all the same. I mean, not all the same. They will have all the same outcomes that you want.
I can't balance
Can show me
ammonium sulfate.
ammonium sulfate. Okay. Sorry, let me write it down. Yeah, ammonium sulfate is your product, or your original, is it? You start with ammonium sulfate, is it?
Yeah.
So you should have this.
Yeah.
Plus what's alkaline?
Sodium hydroxide.
Can. Okay, you should get same thing, water, ammonia, standard. Then the salt is sodium sulfate lah. You should have this. Right.
Yeah.
So to balance, I give you a quick tip. The rest of what you still here can look at my screen. I can see here there's two ammoniums. Can see?
Yeah.
So 2 ammonium means 2 ammonia, confirm. Then I can count 1 sulfate, just nice 1 sulfate. And then I look at my sodium, here got 2 sodiums. Then I must put a 2 here lah. That's the answer, done already. I mean, not fully done yet, then you must check through, because maybe you still need to put a number here. I haven't checked for you, but that's generally how we do it. You can check yourself, can?
Okay.
Okay lah. I have to end the class, so 2 of you just pack up. We'll continue next week. AMS student, can we start in 30 seconds? Hi Faith, long time no see. Last week we did partial fractions. Today we'll do a little bit of that, and then hopefully we can get it going for them to do some work. Then maybe, are you facing any issues with what you need to do in school? You all need to learn log, right? I think many people need to learn log. You all need to learn. Okay, sorry, since you are here, they are taking a break. What are you learning right now, and what's next? Do you know in school? For Faith.
We are learning chapter 2. I think that
The discriminant stuff.
equations and inequalities. Yeah. Then we finished up till chapter 6, but we skipped chapter 5. We skipped logarithms and exponentials.
Okay, you skip. So that one will be after mid-year or what?
That
Or-
one will be
before mid-year also.
I don't. The teacher gave us the topics for WA2 and at the. I don't think chapter 5 inside.
Okay, then okay, let me close it. Who's Izan? Is Izan outside?
No.
Where's Izan?
Maybe it's a bit late.
Oh, he's on Zoom. Okay, thank you. Yeah. Okay. Okay. So. Okay, if I follow my own planning line, after this, I think today we'll quickly finish partial fraction. It's really quite easy. Most people don't struggle with it. Binomial is extremely hard, and so is log. So the next 2 chapters are whatever sequence it comes in. You all can look at our cover page. Okay, partial fraction, I'm gonna take hopefully half an hour to go through a bit. You all can learn in school. It's easy. Ask me anything. But okay, let me discuss with the class. Most guys, please feedback. Okay. I know Xianghui texted me. Xianghui said he need log by mid-year. Can I know between now and mid-year, who is doing both binomial and log?
I have no idea. They don't be
They don't tell you earlier. Okay, let me just type it so we don't. Okay, so now today we'll clear partial fraction, and then I know Faith is still doing what we used to do first 2 chapters, so I know a bit sad for her, but that's why it is. I just want to know moving forward. Let me go to the group chat. Hi. Okay. Who? Okay, because as I said, if we finish partial fraction today, it's left with binomial and log. Binomial and log. Who knows what you need for mid-year? Is it both, or one of them, or you have zero idea? Okay, of course, everything we have learned thus far will be tested, which is for us, the first 3 months, a lot of discriminant stuff. And then we did a bit of long D, we did a bit of partial fraction, the remainder and factor theorem. Okay, but the next 2 are very hard. So I need to plan properly so I can help all of you learn it the most efficient way. So please just reply in the group chat, tell me if you have any idea what's going on or not.